Hello, and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by the students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'll be one of your hosts this evening. I am Judy Tomei, and I'm joined by Dr. Elena Hyde. Hi, Elena.
Hello, hello. It's good to be here.
It's good to have you with me tonight. We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday night at 9 p.m. local Toronto time, that being 2 a.m. Universal Coordinate Time, on YouTube at York U Observatory in concert with our online public viewing program run by the Observatory team. To navigate to the live show or to find out more, check out our website at www.yorku.ca/science/observatory and follow the links to OPV, that's online public viewing, to join in the live chat on YouTube. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can also connect with us on Instagram at the handle at YorkU Observatory and on Facebook at Allan I Carswell Obs. All of our programs are free, but if you would like to make a donation, head over to our website and click on Donate to the Observatory. Once again, that website is yorku.ca/science/observatory. We will be monitoring the chat room for questions and to post content. The current weather is, well, last time I was outside, it was snowing. So I'm assuming we are having archival images tonight.
Yes, I think that's a safe bet.
How are you doing, Elena?
Well, I heard it's the most snow we've had in November, the beginning of November since 1948 or something. So I'm a little cold. We was up in the domes quite a lot today.
Yeah. The snow did come early. We'll see what that means for the rest of the winter. Don't know.
Yeah, and it's very, very tantalizing because if anyone has been interested in trying to see cool stuff, the NOAA Aurora Watch has been putting out all these big warnings
Yes,
about amazing aurora coming soon,
yes.
and there's a great chance tonight, an amazing chance tomorrow, and it's clouds all over Ontario. So
Yeah.
fingers crossed for tomorrow, but
Well, I solved that problem by booking a trip to Yellowknife in
for tomorrow?
January. So, no,
Oh no, okay.
we're going in January.
Okay, okay. Well, fingers crossed for January then.
Yeah.
Um,
Um,
that's going to be really cold though.
oh, yes. We're renting cold weather gear.
Amazing.
That's a
You're going to get
thing.
such a good view.
I am. I'm going to be so cold.
All right, send pictures.
Oh, I will. All
All right,
right.
so Aurora all over, but
Aurora all over, but also clouds. Sigh.
well,
It
I
is
can
what
think
it
of a
is.
way
It
to
is
get
November.
yes, exactly. And if you did want to go above the clouds in November, I do have a way to do that.
Airplane?
Well, it would get us to our This Week in Space and Astronomy History. I would just launch
Oh,
myself out of the atmosphere.
nice. Which millionaire do you know that would put you on one of these?
Oh, that's a good point. I don't know any millionaires.
Mm.
Although, if any of them are listening to this podcast, I am willing to be launched into space, provided that there is some sort of return vehicle included.
All right. Well, speaking of launches, let's launch into our This Week in Space and Astronomy history.
Yes, I mean, of course, what to do when it's cloudy and you can't get to the skies? Well, you can launch yourself through it, or of course, you can spend your time diving into history and doing data reduction. So we'll do that first one, and I'll go back to 1966, either a long time ago or not very long ago, depending on how you look at it. 1966 was a very active time for launching interesting things off of the Earth. We did not have anywhere near the number of satellites in orbit that we do now, but November 6th was the launch of a pretty interesting one. This is the Lunar Orbiter 2. So it launched itself out of Earth's atmosphere and did not have to deal with any clouds once it got away. So, of course, after you go out above the atmosphere, you can keep going through low Earth orbit out to high Earth orbit. And this one was, as you might guess from its name of Lunar Orbiter, headed to the moon. The Lunar Orbiter 2 was designed to photograph these mysterious smooth areas which we see as the darker regions on the moon now. So if you're familiar with the face on the moon, you see that there's sort of some dark patches that kind of make up the face on the moon, and then, the rest of it's quite white. Those dark patches tend to be actually physically smoother area. We actually know now that they are sort of the remnants of ancient lava fields, but in 1966, they weren't that well understood. So we wanted to find out more, and Lunar Orbiter 2 was out to get pictures of the lunar surface. And of course, because it's 1966, there were actually humans on the way to the moon, and they needed to find good landing sites, i.e., landing sites that were not, for example, on the top of a mountain or on the edge of a cliff or off the edge of a cliff. So we needed to find good flat landing sites. And by looking at these relatively smooth parts of the moon, you can get a good guess, which is really all they had back in the day. And of course, 1966, looking at pictures, they were looking at taking photographs, which were pretty low resolution by today's standard. The Lunar 2 orbiter and, of course, sort of its robotic spacecraft. It was part of this larger lunar orbiter program, and these were all launched by the United States sort of between 1966 and 67, which was really to try to find where the Apollo landing sites might be. And if you look at some moon maps now, you can actually find the Apollo mission landing sites labeled and try to spot them or their general location if you want a little bit of moon fun and have some binoculars. You will not be able to, like, to just clarify, you will not be able to see the moon landing sites with binoculars. You'll be able to see the general area where it happened. We do not have that kind of binocular resolution just yet. Quite a large telescope would be needed. So if you want to actually see the lunar landing sites, you'll just have to go there, which means that you, like of course the Lunar Orbiter 2, would actually have to launch yourself over to the moon. And there are some people actually still trying to get human able, I suppose, crafts out there. Now, 1966, a very, very different time for astronomy, very active, of course, lots of human-based exploration, especially of the moon, and getting that photographic data out from the spacecraft required it to read out and transmit. So they had something like about 600-ish quote unquote high resolution frames. And I say quote unquote because it wasn't actually that high, but it was good enough to try to get an estimate for where to land. And there's some pictures that you can actually see online from NASA of some of the areas they looked at, the Mare Insularum, the Arrhenius, I might be saying that wrong, Arrhenius crater or Arrhenius B crater. So they kind of looked at a bunch of different regions from this, and they brought more than just photographic equipment. So like a lot of missions of that time, they were trying to combine various different techniques. And so they had, of course, the Lunar Orbiter 2 camera on there, and they also had meteoroid detectors, so they could look for micrometeoroids in the lunar environment. They had actually detectors for cesium iodide to look for radiation in the environment, which is pretty cool. And of course, being able to take the pictures and return them back to Earth was a special feat of all its own, and it was a success. So this is actually a story with a happy ending, which doesn't always happen when you launch things on giant piles of exploding rocket fuel. So, it did get there. It did return its images, and the spacecraft, of course, as I say, was launched in November 6th. So that would have been 4 days ago, but in 1966. And it was deorbited, is I believe the word they use for no longer in orbit or crashed into. So it was deorbited a year later-ish, which was October 11th, 1967. So about a year later. It lasted a reasonable lifetime, but it hasn't the lifetime of some of these other missions that we've seen, of course, famously Voyager and stuff like that. So it's a really fun little mission. The little mission that could, it succeeded. It got pictures. It sent back data, and of course, at the end of its lifetime, it was deorbited in a not terribly spectacular fashion, and because it's 1966, it was actually a little bit of fun. Part of a expendable launch rocket system used at the time called Atlas Agena, which was basically derived from a Atlas missile. So very interesting times, the 1960s. And a similar rocket launcher was used to launch some of the first five Mariner uncrewed probes, which we've talked about before on this show. And what you'll see is over time, various different rocket technology has changed quite a bit. So if you go back and look up the old Atlas Agena expendable launch systems and compare them to some of the more modern launch systems from NASA or SpaceX or other countries, reusability has become a much bigger factor, which is a little bit of a fun note. So I'll just
Yeah.
give a little greeting to Lunar Orbiter to thank you for your service, I suppose.
Yeah, that was definitely an interesting period of time, the lead up to the Apollo missions. There were so many missions sent to the moon to try to learn as much as we possibly could before loading some people onto those, bajillion tons of exploding materials and send them up there too.
Yeah, and of course this was, something that had built on decades of work that had come before, which I think it goes to your your history item.
Yes. So we are heading back to 1911, the 11th of November, with the birth of Luigi Broglio. He was an Italian aerospace engineer, Air Force Lieutenant Colonel, and Dean of the School of Aeronautical Engineering at the University of Rome, uh, Sapienza. Um, he's sometimes referred to as the Italian von Braun. Um, he was the architect of the San Marco program, and he was born in Mestre near Venice. His family moved to Rome in 1915, so when he was about 4 years old. He graduated with a civil engineering degree in 1934 and completed 3 years of military service as an artillery officer in the Army. When he finished that posting, he applied to the Italian Air Force. That is the Aeronautica Militare Italiana, or the AMI, becoming the first lieutenant and becoming a first lieutenant, and was assigned to work at AMI Research Center in Guidona Montecelio. He worked on aerospace projects, including jet engines, until armistice in Italy in September 43. And then he fled the occupying German forces, joining a partisan group. He became the dean of La Sapienza School of Aeronautical Engineering in 1952 and formed the Centro Ricerche Aerospaziali, CRA, establishing a supersonic wind tunnel in Italy. He was assigned as leader of the Air Force's munition research unit, um, which was responsible for the military's rocket program in 56. During the time, he was involved in weather experiments using Nike Cajun rockets, and they were using those to release sodium clouds for study. After the launch of Sputnik 1 in 1957, everyone wanted to launch satellites. And physicist Eduardo Amali convinced Broglio to support this. And together they helped form the Italian Space Research Commission, of which Broglio was the president. Um, the commission was successful in lobbying the Italian government for a national program to set up an offshore equatorial launch base with the support of NASA, rockets, and crew training. This led to the launch of San Marco 1, the first Italian built satellite. He continued his Air Force career and academic career at La Sapienza and was also the director of the Italian Space Agency from its foundation in 1988 to his retirement in 1993. The San Marco Equatorial Range was renamed in his honor at some point. And he also has an asteroid named after him, which is asteroid 18542 Broglio.
Very impressive. I have to say, I had not I had heard of him, but I hadn't realized he had done all of that. What an overachiever.
Especially, it's a lot. And I haven't taken the time, but I'd be interested to like get more details about like what was happening during the Second World War.
Yeah, and a lot of it's really interesting with the early rocket study, especially because it's hard to understate, or it's hard it's easy to understate, hard to overstate how really crazy and dynamic and dangerous and amazing some of these early rocketry experiments were. And it's really interesting to hear about, of course, the this particular Italian contribution, because a lot of times we do unfortunately focus on the US space program because they sent humans to the moon, but they wouldn't have been able to do it without work like this.
Yeah. I always like digging into like I have some Italian background, so I'm always interested in like learning what Italy was doing. But I'm always interested in learning what lots of other countries that aren't, the US and Russia or the USSR, depending on where we are in time, what those countries were doing. Because this was, Italy was among the first countries to put a satellite into orbit.
Yeah, exactly. And I think it's a lot of times missed just how important those contributions were um, to the final successes that did happen. Because, unlike in space, we're not in a vacuum, and all of the research and work that went on, feeds back through collaboration. And of course, he was working with the support of NASA rockets for his for one of his items you mentioned. And I'm sure they benefited from that as well.
Mm-hmm. I also find it interesting that, they they were successful in lobbying for this sort of program. I mean,
Yeah,
it it's not that long after the end of the Second World War. I mean, Italy was in the thick of it, so like there was, I imagine, a lot of repercussions, just rebuilding. And so to be able to convince a government to like, hey, let's do some space stuff is no small feat.
absolutely. And I just, because you mentioned the asteroid, I had to look it up as well. And because we are in Ontario, I did want to just point out to folks that if you do have a reasonably good telescope, the 18542 Broglio is visible tonight, the 10th of
Yes.
November, um, after sunset until about 4 a.m., so near sunrise. So it is actually up almost all night tonight. Um, and it reaches its highest point at around about of 11:30 p.m. Um, so if you have a reasonably good telescope, you might actually be able to see his asteroid. It's not particularly bright. It's 17th magnitude.
Hmm.
So we could do it with the 1 meter if it wasn't snowing. But just so you know, there is still actually the possibility to loop in a little fun asteroid observing if you've got a pretty good scope and clear skies tonight.
Very cool. All
We can
right.
even get a free rocket inspired observation.
Love it. All right. So let's move on to, I guess, a different part of the world.
We're gonna keep launching things. In fact,
Yes.
I'm so excited about launching things. I found something that got launched and almost used. So if anyone's been following the news recently, you probably heard of this really kind of awful idea that's come out recently for giant mirrors in space to reflect sunlight at night. This is recent, so I'm not telling you the history item yet. But there's a company who's come out with this called Reflect Orbital that we might talk about later when we get to the news area. However, this is not necessarily new. On November 9th, in 1998, there was a lot of news going around about an ambitious Russian experiment that would light up London, Brussels, Seattle, Kiev. They could be cities lit up from space. And this was all the rage in all the news stories of the November 9th, 1998. I mean, if you knew where to look. Obviously, there were news stories that weren't this. But big news. This aerospace consortium launched a giant mirror in 1998 that was going to reflect sunlight down to Earth. If this sounds familiar, it should, because we just heard the same thing in 2025. Now, in 1998, it was a Russian experiment that was going to build a giant mirror that would reflect sunlight down to Earth. This mirror, if it had worked and operated as designed, would have appeared 10 times as bright as the full moon. Astronomers were aghast, and they are again today, but in 1998, people were very disturbed by this. So, what is it? What's it called? Well, this particular one is actually Zenaima, and I might be saying that a little bit wrong, Zenaima 2.5. So Zenaima 2.5 was set for November 9th. It was a follow-up to Zenaima 2, and they both had the same idea, but as you might have guessed from this 2.5 being the follow-up, Zenaima 2 really didn't work out well. So Zenaima 2 was a 20-meter wide space solar mirror that was previously launched, and it was deployed from the Russian end of, sorry, the end of the Russian Progress spacecraft, which is an expendable cargo spacecraft that they had at the time. Now, this one was deorbited after a few hours and burned up. Actually, and this is really just, I couldn't make this up if I tried. It burned up in atmospheric reentry over Canada. So, in a way, this is very much reminding me of the many pieces of space debris that have come flaming down into Saskatchewan and other parts of Canada recently. I feel like it's current news, but this was again 1998, 99. So Zenaima 2 burned up in atmospheric reentry over Canada. The mirror that they had for the original Zenaima 2 was actually a prototype of a solar sail, which is kind of cool. It was repurposed as a space mirror for illumination because solar sails, I don't know, got less popular around that time. But it didn't really do what it should have. Zanimia 2 experiment um, never lit up anything on Earth. It went around a couple times and burned up. Zanimia 2.5 um, should have should have illuminated something on November 9th, is what they were saying. It was actually deployed earlier, um, and of course, was launched even earlier than that in, I believe, 1990. I can get my days right. 1998, about I think it was March or so. So the 2.5 was bigger. It had 25-meter diameter, which is really quite large, and it would have produced a bright spot 7 kilometers in diameter once it had reflected down onto Earth, which is not nothing. 7 kilometers in diameter. So think about running a kilometer and then doing that another 6 times, and it would still be under that illumination area. So potentially a huge problem for observatories, but fortunately or unfortunately, depending on how you want to look at it, for Zanimia 2.5, instead of deploying on November 9th and lighting up part of the world, it tried to deploy, and the mirror actually got caught on the antenna of the Progress, which was the Progress spacecraft, which is an expendable cargo spacecraft. It got caught on that antenna, and it ripped, and that was it. So there were a few attempts by the mission control from the Russians to get the mirror free from the antenna, but they couldn't do it. And it was also, as I say, deorbited or burned up into Earth's atmosphere. I don't know that they ever found where it landed, and I don't know that it actually burned up over Canada, but Zanimia 2 definitely did. So it's sort of the I suppose everything old is new again. But it's really interesting that if you go back and look at the 1998 arguments against this giant mirror in space, a lot of them are still still very valid today. There's a great quote actually from a New Scientist article that says astronomers are aghast. And there's a quote from Daniel Green, astronomer at the Harvard Smithsonian Center for Astrophysics in Cambridge, Massachusetts, from 1998, and they put this in print, so I can quote him, but his actual quote says, "I cringe to think that we could lose the night sky because of all these companies with their brain dead ideas." So that's from 1998 to today. So um, a little bit of history, a very interesting, of course, satellite launch, and a somewhat accident plagued set of missions, which fortunately, or maybe unfortunately, if you're really hoping for some, I don't know, disruptions to astronomy and wildlife. And as a little point of interest as well, the rocket was also named Progress. So the Progress spacecraft is the little reusable cargo craft, and the rocket that was launched from Baikonur was also a Progress, but Progress M15. So just in case we have any rocketry fans listening.
Okay. Why?
Well, that's a good question. I mean, they did say that, of course, this was a little bit of an experiment, right? So it was launched by something called the Space Regatta Consortium, which
Hmm.
was a set of companies, and I'm not sure which companies were involved, but probably I'll leave this as an exercise to the listener. Go and look it up. Um, which companies were involved, but they were hoping to get interest in their plan to use 200 of these. So they were going to launch, if it was successful, they wanted to launch 200 to bring sunlight to the Arctic. Was And that's a quote from New Scientist 1998.
D- d-
um, yeah,
Does the Arctic want sunlight during the like?
I
Okay.
mean the telescopes don't, I'm sure.
Well, I'm also thinking like climate change is bad enough. We're gonna.
Yeah, this would have
Mm,
been worse for that. And I mean, 200 of them was their plan. Now, if we compare that to the modern plan that has been put out by a modern company
uh-huh.
today of the Reflect Orbital, it's strikingly similar. They want to launch something that reflects down back onto Earth, and they're looking at going from 10 by 10 meters to even 54 by 54 meters in the size of these things. And they say that they could put 3,000 of them into orbit.
Yeah. I wish
And
them many failures.
that's what's happened today. But I'd just like to say, for all of us hoping that doesn't happen, it only took three abject failures for the last people to give up.
Okay. Yes. I wish them many failures. Because that's just ridiculous.
Yes. Well, and some satellites we wish the best. Other satellites maybe not so much.
Yeah, yeah, yeah. I mean, generally speaking, I'm not against satellites.
No,
Uh
there have been some wonderful satellites, just maybe not these ones.
yeah, yeah, yeah. Not these ones. All right. Let's move on to a more different satellite.
A better
Um,
satellite.
a better satellite. So we're going to November 3rd, 1997, with the deployment of Sputnik 40, which was also known as Sputnik Junior, PS2, or Radio Sputnik 17. It was a Franco-Russian amateur radio satellite launch to commemorate the 40th anniversary of the launch of Sputnik 1. It was a one-third scale model of Sputnik 1, and it was deployed from the Mir space station. It was built by students and constructed at the Polytechnic Laboratory of Nalchik in, oh boy, Kabardino-Balkaria. And I hope I got that close to right. The transmitter was assembled by Jules Ridelet College in Réunion. I guess that's probably Jules Ridelet College in Réunion with technical support from AMSAT France. It was launched from the same launch pad that was used to launch Sputnik 1 aboard a Progress M36, which docked to Mir on October 8th. The satellite was transferred to the space station and deployed during an EVA by cosmonauts Anatoly Soloveyev and Pavel Vinogradov. It went into its final orbit the next day on November 4th and operated until December 29th, 1997, when its batteries died and its orbit decayed on May 21st, 1998. There was a backup satellite that was sent up to Mir as well. It remained there until it was destroyed when Mir was deorbited in 2001.
My goodness. And again with the Progress rocket.
Yes, this actual progress.
And it's so interesting that they put in the radio call signs as well, because that was actually a really popular way of tracking them apparently back in the day.
Nice.
And little fun fact, there are receivers today that you can buy to pick up satellite signals if you want to know what people are saying as they fly overhead. So there are a few different satellites that send back data to Earth that you can actually collect the signals for. I don't have the list offhand, but I know some hobbyist folks still like to watch them.
Nice. So are these like just sending down data that doesn't need to be encrypted because it's not like
Yeah, I think it's mostly science data and stuff like
Yeah,
that.
not those spy satellites.
Not that I know of, but I wouldn't know about those. Just put that out there right now. I definitely do not have any receivers to pick up spy satellites, just in case anyone's wondering.
I don't have receivers that pick up anything, so I think we're safe.
We did have a couple students actually come by with some receivers, and we were able to pick up something coming down from one of the weather satellites at one point, I think.
Cool.
So it is pretty fun. They have little tiny ones that you can plug into your laptop and just watch the signal as the satellite goes overhead. Because of course, as the satellite's traveling over, you only get the signal for that amount of time,
Yeah.
which is really fun because if you're tracking the satellite and getting the signal, um, it's pretty neat.
Neato.
Yeah, and it's fun to know that back in, of course, 1997 and before with Sputnik 1 even, um, people were watching on radio or with other types of transceivers or receivers, I should say.
Beep beep beep.
Yeah, so fun. So if you've got a I don't know ham radio, maybe see what you can get.
Cool. All right, folks, you are listening to York Universe. We are broadcasting live from the Allan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. For chat, questions, content, head over to yorku.ca/science/observatory. Tonight, you're listening to myself, Judy Tomei, and Dr. Elena Hyde, and we are just wrapping up our This Week in History discussions. So swing by our website for online viewing. Click OPV in the menu bar. So Elena, we have a reminder, or I guess something
Yes,
new happening.
a few reminders, and I did just want to let our listeners know that I have checked really quick. I remembered ham radio was possible, but I did just have a quick look to check, and there is actually several websites that will show you how to talk to satellites with your ham radio.
Well,
So
that's
there's a
cool.
whole bunch of tutorials out there. It wasn't just me remembering one or two things, but there are some really fun practical techniques for space comms. So hobbyists galore. Now that's not the reminder I was going to give you all. But I got distracted. So, snowy, cloudy weather this week in Ontario. So there is actually no Wednesday tour this Wednesday at the observatory, unfortunately. They are all free, but this week we will not be giving you the free in-person tour. They'll be back on next week. However, we have something else that's free that we will be giving everyone because it's actually launched onto our webpage. This is a program that I have been creating over the last year or two. It's called Stellar Scholars, and it's on our same webpage that Julie's been telling you about all over, the yorku.ca/science/observatory. And if you go to our website and you click on the Stellar Scholars, or you go to the outreach area, what you'll see is that we've put up some of our educational stuff. So we give lots of tutorials and games and tours for high school students and grade school students and just for the public in general. And so we thought, well, why not make some of this public as we have time to or as we can. And so I've made a Stellar Scholars area, which is on a different page linked onto our page, that has a teacher's portal and a student's portal or a modules list. So anybody who wants to learn a little bit about space, it's all up there 100% for free, 100% volunteer created. It's just there because we wanted to share the knowledge and provide the resources to everybody that can have them forever. We have 6 modules at the moment, which I'm pretty happy with. We've got a little introduction to the telescopes at the observatory, some galaxy stuff, some moon stuff, about innovations from space, and of course, a little Indigenous astronomy module, as well as some careers. Now, all of those are up with some certifications, and I've put up all of our favorite resources and games as well. So I hope you all enjoy it. If you're a teacher who wants to use it and wants a bit of help, or you would like an observatory member to come and run this module for your class, or you just have questions, or you'd like us to design a module for you, you can email us at observe@yorku.ca and just enjoy, everyone. Have fun with it. It's been a long time coming, but it is entirely up there for everyone for free, and we're really excited about it. So I just had to put that in the reminders because it's well, it's a little bit of my new favorite pet.
I poked around on the website earlier this week. It looks fabulous. I shared it with my colleagues who are, you know, learning astronomy. Um, and I think it could be a great resource for folks, training staff as well, whether they
Absolutely,
work at
absolutely.
planetariums or observatories, that sort of thing. So I'll be sharing it widely.
And we have in our list of resources as well on our resources area, we've linked to a lot of our other favorite tools here in Canada, and that includes, of course, Spaceplace and a few other ones as well. So I'm hoping we can make it a little bit of a fun reference area resource for everybody.
Nice. Well, excellent work, Elena and team.
Absolutely. And that's the other fun thing. I've actually managed to capture pictures of almost all the students who've worked on it. And
Amazing.
they're all featured in the authors page,
Wonderful.
which is always nice.
Yes. All right. Shall we dive into the news?
Yes, lots of news. So I've been a little bit on like a bad satellite rant here. So I thought, with the news items, I might go ahead and just continue bad satellites. I've already talked a lot about the reflect orbital giant mirrors in space. That is brand new news. They're still planning on putting mirrors into space. As you, Julie said, I hope they don't, or I hope they fail, if that's allowed. But in the news right now, it's not just giant mirrors. We also have a bit of a satellite, shall I say, um, problem in the sense that because these satellites are so numerous and because they have started to collide with each other, and every collision is producing more and more fragments, we now have tens of thousands of things in space orbiting around. Most of them are untracked. We've seen space debris coming down in Saskatchewan. We've seen increasing space junk. The current estimates are something like three very large pieces of space junk come down every day, and it's only going to get worse. So, in the news on bad satellites, I actually have two of really interesting ones. Just 2 days ago, on November 8th this year, people were down in Florida in the US watching the launch for one of the SpaceX Falcon 9 rockets. And of course, the really ironic thing is, this rocket was on a Starlink mission. So it was sending more satellites into orbit, which is just going to increase the problem with space debris. And as the launch was happening, um, or trying to happen, this giant fireball came in, and they're not totally sure. So I have to put just a little tiny bit of salt in there. We're not 100% sure what the giant fireball was, but there's a very good chance that it was actually a piece of space debris coming down as they were trying to launch more potential space debris. So
Womp womp.
uh, this was just 2 days ago, and the videos are still out. So if you search for the SpaceX Falcon 9 rocket launch on Saturday, November 8th, it was from the Cape Canaveral Space Force Station. Something was spotted in the sky. So there's a lot of videos online, and from the videos and from the color and the size of it, it does seem much more likely that it was a piece of space debris that came down um, as they were attempting to launch more space debris. So that's actually only the first part of the bad satellite things that have happened very, very recently. We had not just 2 days ago this, but there were, you know, a very much more serious problem happened just a little bit around the same time. There were 20, let's see, Shenzhou astronauts at the Tiangong station, the Chinese station, in April. Um, so what happened was that those 20 astronauts had their replacements um, with the Shenzhou 21 mission docked, and they raised the crew size for that. So they had the Shenzhou 20 was the previous mission, Shenzhou 21 was the new one. So they kind of keep them in track like we do with the ISS. But this means that they had a total of 6 astronauts, and they're going to do a handover ceremony to transfer command of the outpost to the new crew. And this was Tuesday. So let me see if I can Tuesday last week, if I can subtract that many days. So Tuesday last week, and about 24 hours after getting ready for that, they decided to call off the departure from the Tiangong station, and it looks like it was a space debris collision that caused the problem. So they're worried that the Shenzhou 20 spacecraft may have been damaged,
Ooh.
and that it was um, likely a space debris contact that happened. And we've seen astronauts at the ISS have to shelter from warnings of space debris. Um, but now they have 6 astronauts up there, and the the ship itself has a landing capsule, crew quarters, power and propulsion module, um, and it's pretty unusual that we actually hear about an ongoing space mission problem from the Chinese space station. So it does make me kind of think that perhaps, you know, perhaps it was something slightly more serious. We know that they lost part of their power when a piece of space debris hit a solar panel in 2023. So it is very dangerous, and it's worth noting that with these kind of you know environments, you're in space, you're very heavily dependent on your capsule staying completely intact. And the ISS has had its run-ins with small fragments of debris. There was one back in 2021 where they had about 1 millimeter piece of space debris, which is too small to be tracked from the ground. And this very small 1 millimeter size is really dangerous, and also one of the things that happens when you have extra collisions, you get more of these really dangerous small pieces. But it punched a hole in the ISS Canada arm, actually. So it literally kind of punched us in the arm. It punched
Wow.
us in the Canada arm. And fortunately, the robotic arm was not really affected for its performance, but it could have been. And if it had hit a more sensitive area or hit a slightly different area, it might be a very, very different story, and you could very well have some real danger to the humans. Now, for this one particular, we don't have a ton of information, like I said, because they haven't given us a lot of info from the Chinese space station, but they're trying to find out if the spacecraft is going to be usable for reentry and landing. And of course, it wasn't that long ago where we were looking at astronauts stranded at the ISS. Well, it looks like we might now have astronauts stranded at the Chinese space station as well. If it's damaged beyond repair, they'll actually have to send a different spacecraft on a rocket that can launch a rescue mission, and have to go get them that way. So it's something to, I suppose, cross your fingers for the astronauts up there. Hope it's not too serious, but it is definitely some very, very bad bad satellite bits that have been in action recently. So yeah, we have had some interesting news, but a lot of yes, a lot of satellites misbehaving.
Yeah, wow. And we all know what could happen when you have a damaged spacecraft. So,
Yes, if you've seen any sci-fi, you know that decompression is very bad.
well,
And
I
you
mean, I was thinking actually like uh Columbia.
Oh yes, yes. I think that's probably one of the most famous, yeah, maybe the most famous of all of our accidents.
Hmm.
And it's just your environment is so sensitive.
Yeah.
So fingers crossed for them, and hopefully they
Yes.
do get back to Earth safely.
Yes. Here, here. All right. Well, we're going to move from bad satellite to good satellite.
Yes, good. So this I wanted to end on a happy note. So take it, take us to our happy place, Julie.
This may even be like, arguably best satellite.
And
Uh
yep, you could make that argument. Yes, absolutely.
so this is James Webb Space Telescope news. It has made the first ever detection of complex organic molecules around a star in a galaxy beyond the Milky Way. So complex organic molecules, short form COMS, have been discovered around a young protostar outside the Milky Way because JWST is awesome. The team was led by Marta Svilo of the University of Maryland, and they used the JWST's mid infrared instrument. Um, the comms were detected in ice around grains of dust surrounding protostar ST6, which is found in the Large Magellanic Cloud, or LMC, which is a dwarf galaxy companion of our own galaxy, the Milky Way, and it is about 163,000 light years away. I can speak numbers. COMS are molecules containing carbon, which have more than 6 atoms. And many COMS are chemical precursors to molecules such as amino acids and RNA and all those cool things that we look for when we're looking for signs of life. COMS around ST6 include uh, acetyl, sorry, I am not a chemist, acetaldehyde, acetic acid, that one I know, ethanol, I know that one, methanol, that one too, and methylformate. Methylformate and acetaldehyde are used as industrial chemicals on Earth, and methanol and ethanol are alcohols, and acetic acid is vinegar. Um, at least 14 other columns were found, but have yet to be identified by the team. So the stars form from clouds of molecular gas that have begun to fragment and collapse. And at first, the material is very cold. We're looking at about 100 Kelvin, and complex molecules are ices on dust grains at that point. Um, as the system gains heat due to the collapse, the ice sublimates and releases COMS as gases. And these gases have been observed in the Milky Way and the Large Magellanic Cloud in the past, but this is the first time that the compounds have been observed in their ice phase outside of the Milky Way. It's only the fifth time that icy COMS have been observed at all. Observing this earlier stage of star formation allows astronomers to better understand the processes involved. And the LMC is different from the Milky Way The conditions there are more like those in galaxies from when the universe was younger, when the abundances of elements heavier than hydrogen and helium were lower, and there was more UV radiation. So the lower abundance of heavy elements could impact the abundance of comms, and the UV radiation could have an effect on rates of reactions. So, because of this similarity to the conditions in the early universe, studying the comms in the LMC can help astronomers understand the organic chemistry of that earlier time and how soon the building blocks of life could form, and maybe even place limits on when life could have first formed in the universe. With respect to water ice, the calm ice abundances around ST6 are lower than those measured around the protostars that were observed in the Milky Way, except for acetic acid. And that overabundance is likely due to the flux of UV radiation. Calms that are yet to be identified may include glycolaldehyde, which is a chemical precursor to ribose, which is a component of RNA, but more laboratory spectra are needed to confirm the identification. So once the system heats up, the gases are released. More reactions are triggered by UV light, leading to larger and more complex molecules that are important to life, such as propanol and propanal, and possibly amino acids. None of these have been detected around ST6. Amino acids have been found in comets and meteorites in our solar system, since these are bodies that formed 4.5 billion years ago when our sun was a protostar itself. This could be what lies in the future of ST6.
Very nice.
Yeah.
And of course, protostars are just really, really interesting because they are themselves hard to see, and that's why ideal candidates for James Webb Space Telescope with its infrared capabilities and getting to kind of see inside the dusty, cloudy environment is a real treat because you do get just such a wonderful stew of compounds and possibilities, shall we say.
Yeah. Yeah, it's true that, because protostars don't have nuclear reactions happening yet, it's really like IR radiation from that increase in energy from like gravitational potential energy. And there's so much dust out there, very difficult to observe.
Yeah, and of course, the question is, in the end, if you're looking for, how do you make compounds like RNA and get them into places where they could form up and start creating life with other chemical compounds that you need. One of the questions is, of course, if you've got a protostar, how heavy do the elements need to be at the start, and how important is the protostar version for building those more complex things? Because once you turn on your once you turn your star on, shall I say, it's going to put out quite a lot of light and sort of blast your heavy or your lighter stuff and clean out your solar system. So if you don't have it in place by then, um, are you even going to be able to form anything else interesting? So yeah, how it all comes together is a really fun question, and the UV radiation um, is so important. And the LMC is the perfect place to look because it's much more transparent than the Milky Way, and we're not in it. So it really is looking in the perfect place, and really it's exciting mystery.
Yeah. And as far as like other galaxies go, it's nice and close by.
Yeah, I mean, and eventually it will be part of the Milky Way. So, I mean, it's
Not for a while yet.
basically, yeah, not for a while. It's going to be well past the end of this broadcast before before it
Oh,
gets here.
yes. Yes. Another thing I find interesting about this is that, like we've got this data from JWST, and now we need some chemists to do some spectroscopy. So we have things to compare to, so we can identify these other things. Um,
Yeah, it's very cross-disciplinary, which is
Yes.
really fun.
Yes.
And it's a, you can't do astrochemistry without the chemistry.
Yeah. Go meet those people in the building next door or whatever. Have lunch with them. Talk about their data.
Yes,
Talk about their work.
yes, yes, send us your data.
More data.
On that note, all we need is a clear skies and
Yes. Well, it's always clear skies for JWST.
that's true. I mean
Mhm.
for the 1 meter, but yes.
Yes. The clear skies will come.
Indeed,
All
we
right,
just have to
folks.
wait.
Mhm. All right, folks. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Dr. Elena Hyde and myself. You can always connect with us on Instagram at the handle at York U Observatory and Facebook at Allan I Carswell Obs. Check out our website for show notes, content updates, and contact info at yorku.ca/science/observatory. Thanks for tuning in. Clear skies and have a good night.
Clear skies, everyone.